Okay, so hello everyone, welcome. For me this is the first day of class, for you is probably the second day of class. So for those who don't know me, I'm Pam Ishmael. I go by Pam, I'm informal. I've been here in this department for about 11 and a half years, and this is my 11th year teaching this class. So, and I'm excited, again, I'm always excited, and I try to get you guys excited with me. We'll see how that goes. So before I go into introductions, talking about the class a little bit, I wanted just to say that as of today, I have about 29 people registered in the class. Now, 3 did not show up, so I might drop them off. But if we continue to be 29, I would like to open the Monday section for lab. So currently I have 29 students on Wednesday lab, and this is the way we structure the lab. That won't work for your own educational purposes. Hello, what's your name? Jillian. Hi, Jillian. So we got Jillian. So what I'm going to do, and I'm going to urge you to please consider, hello, mister. What's your name?
Evan.
That's Evan. Okay. I'm going to, Cindy prepared a sign-up sheet for us. You don't have to change registration into a new section. Just sign up your name here if you can do the Monday lab. We are really looking for 14 or 15 people to switch. So if you don't have anything, Monday is the same as Wednesday. It's actually is probably a little better because we're fresh and ready for you at the beginning of the week, not tired. So please go ahead and sign up. I'm just going to pass it through. If you're interested, Cindy, you want to say something? Yes, lab, I sent an email out. Yeah, labs start next week. So if you sign up for Monday, your first lab would be on Monday. So please, please do consider for your own benefit and the entire class benefit to switch to Monday. Okay. So with that, I'll go ahead. First of all, I record lectures, so you should have access to the Canvas. I structured the course. It's new for me to transition from Moodle to Canvas, so hopefully I didn't screw anything up. So hopefully you'll find the information you need, and then I will post recorded lectures every time. So a few things I want to go over with you, only if I find my cursor. There it is. So handouts, I just emailed you the things that you need for the first day of class, but all of this is on Canvas. So I'm going to open up Canvas now and show you a few things. Okay, I'll move it. So this is the home page. Obviously, it's just giving you general information about class schedule. So I'm your main instructor. We will have guest lecturers. We will have Gary teaching GC and MS, and we will have Dr. Labuza, Ted, teaching moisture and water activity. Other than that, it will be me teaching everything else. And we have our returning lab coordinator, Cindy Gallagher, in the back. She'll be working closely with you in the lab. She oversees our lab and work with our TAs to make sure everything works out really well for you. Incoming teaching assistant for the first year, we have Rachel, my PhD student. She's first time TAing and first time really taking this class in general, right, Rachel? As a student, she had it in a different institution. So welcome, Rachel. And then we have Lucy Hansen. Lucy was a student and used to sit in one of these chairs here up front, and she's now a master's student. And then Myson. He's a returning TA. He TA'd last year, so he comes with experience and also took the class about 3 years ago or something like that, 4 years ago. So you are in good hands overall with TAs and Cindy, and so hopefully you have a wonderful lab experience as well as hopefully lecture. So where I post things usually is a little different than Moodle. So here you have modules. So if you go to modules, you'll find everything you need. So you have different folders. So here's your folder with the syllabus, the course schedule, and student learning outcomes. So I encourage you to look at the syllabus. There are a lot of information, and I know probably many of you don't look at it, but there are really useful information to look through the syllabus. I'll go over a few things of the syllabus with you, but course schedule, it also indicates the lecture topic, the labs, some exams and quizzes, and the final exam. So everything you'll find there. And student learning outcome is basically a document, and I'll show you that here, which is very helpful when you're studying. So it's kind of a study guide, rather not so much in depth, but it at least gives you an idea of what you need to learn. So I have it divided into general, overall, like from the entire course, what you're expected to do and learn at the end. And lab is a really big part of your learning in this course. So although there will be 3 lectures every week, but lab is your main learning place. And then you can see that for every section, for like first chapters, for example, you would have certain learning objectives, and then for chromatography, for spectroscopy, for composition and analysis, for chemical properties, they're divided that way. So you will see that this will be helpful when you study these different sections. So please use that as a tool. Again, if you go back to modules, so you'll find a lot of important resources. So lab information and guide, this is really important because you're going to find lab report format. We'll talk about that next week in lab. The grading guide for your lab reports, which you will print out for every lab report and you'll attach it to your lab report. How do you use references in your lab report? So there is a format document with that. And then there are general lab information documents. We will talk about them in lab, not the first week, the second week of labs. So sample quizzes and exams. So here I posted all of the quizzes and exams I gave last year. So you will have an idea, and I encourage you when you study, go and solve the quiz. So you have the quiz with question, for example, and then after you solve it, you can look at the key. So last year I gave 4 quizzes and 2 exams, and here they are. So it's good studying tool after you study, not before you study. After you study, I encourage you to look at those. There are textbook questions, study questions from the book. Sample lab reports, this will be populated after you submit your lab report. So basically this is a writing intensive course, and so you are going to learn how to write lab report in a scientific manner using literature, writing discussions, writing abstracts. So sometimes you need some sort of a guide. The first lab report, I guide you through it and I show you pre-hand an example, but I don't necessarily post it before you actually submit it. But once you submit a lab report, I will select the best, or not the best, a good lab report from you guys, and I will post it here after I grade it. Then you will see for next lab report what you did right, what you did wrong, how you can improve over the course of the semester. So this will be populated as we go through. And also what I will put here is lab report question key. So every lab report will have a set of questions. You will answer that. After we grade the lab reports, I will post the key. This will be part of your studying material because lab is a big portion of the course, so a lot of the questions on the exam come from the lab. And then when I give you quizzes and exam, I'll post the key here, so you'll find them there. And then below that, you will find week 1, 2, etc. You will have a folder for lecture material where I will post the lecture slides. Some of you might have already bought the entire packet, so you have whatever you need is there, and whatever you have here is in your packet. And we also post lab material. So anything that you need for a particular lab will be found here. So there is a pre-lab quiz that you need to do before you come to the lab. You'll find it here the week before. So on Friday maximum, I will post the pre-lab quiz. So over the weekend, you solve the pre-lab quiz and bring it and turn it into your TA at the beginning of the lab. So you'll find that information there. I'll be sending you weekly reminders emails, so that don't feel overwhelmed now. I will remind you of things every week of what you need to do. So that's Canvas. So hopefully you'll find it helpful. There's a textbook and a lab manual. So here's the 5th edition of your textbook, and also the 3rd edition of your lab manual. So you will be needing this for the lab. Some of the labs will be directly from here. Other labs we have addendums for. You will be given those. I believe there is an online access for both through the library. Please double check. I encourage you to get the books. It's a great resource to have, but if you don't want to purchase it, I believe it's available online. Okay. Talked about student learning outcomes. Labs, I'll talk about that more during lab next week. We'll describe what I mean by rotational labs. Already showed you, talked about these. Project. We used to have a project for this class, and I still believe that it was a great thing for students to work on. But I realized over the past few years that students just run out of time during the semester, and they say it's a lot of work. So I'm going to try a year without project. So you guys are super duper lucky. Or not, because they benefited a lot from it. Well, my sin. Anyway, so it used to be a lot of time for me and for you, for students. So we're going to try a pilot without it and see if you're still going to learn what I would like you to learn without having a project. So we'll see. Okay. So this is all. I put this in a presentation mode, and then I have a few questions for you. Oh, actually, no, I didn't go through one more thing on the syllabus. Hold on. I want to show you the grading, what you will be graded on. The cursor. So I changed a little bit, again, the requirement for this course. Again, taking into consideration students' comments from previous years. I used to have 4 quizzes. I'm only going to give 3 quizzes this semester. It was just some quizzes were very close to some exams and overlap with other quizzes from different courses, so I thought maybe 3 quizzes would be enough. So I'm going to have 3 quizzes, but instead of having them each quiz be 25, I added 5 points, so each quiz is worth 30 points now. instead of 25. So when you look at last year's quiz, it's not exactly the same in point distribution. And then there are going to be, instead of 2 exams, 1 midterm and 1 final. So you will have, instead of 2 exams, 1 exam. So that is different from last year. So less exams and quizzes. Lab reports remain the same number of lab reports. We'll talk about that in lab. And pre-lab quizzes, like I said, you do for each lab, you will submit a pre-lab quiz, but we grade only 5 randomly. So each one will be worth 10 points, so that's 50 points. You will be keeping a notebook for lab. We'll talk about that in lab next week. Please bring a lab notebook with you. Any lab notebook. It doesn't have to be any specific lab notebook, but something to keep record of what we do in the lab. And that will be graded for 50 points. Participation, involvement, and attendance. Obviously, you are college students. Coming to class is your own choice, but we'd like to have you here. And I like to have interactions rather than just lecturing. I like to interact with you. This will be counted. So if you talk, it will be counted. But if you ask a question, it will be counted. If you answer a question, if you pause a comment, it's just going to be counted. Talk to me, you'll get 2 points every time you talk to me. But obviously there is a limit. 15 participation will give you 30 points, and then involvement and attendance, that's 20. Attendance, one day I'm going to walk in and whoever is in the class, I will give plus 10. So let's see when that day, and then when I'm in a good mood. So maybe that will give you 10 points. So that's that in terms of point distribution. There's a lot of points to earn. So not only 1 midterm and 1 final, and if you don't do well in one, you fail the class. There's multiple opportunities to get points. And you can see, look at lab reports. 290, even more than the final. So do well in lab, give time for your lab reports, and that is a big portion of your grade. Okay. Now I can go back to this. Any questions in general about the course, the grading, comments? So now for participation today, say your name, and because we don't know you very well, it would take us a week to learn your name, put name and face together, and then they will count participation. So yeah, any questions before moving on? Okay. All right. All right, so let me know what you heard about this class. Did you hear that it was hard class? You all agree. I see everybody nodding. Okay, what's your name?
I'm Sam.
Yeah, Sam.
I guess I've heard about this class that, well, it's hard. There's like a definite payout that you get if you put in more work, your grade will go up. Just if you work a lot, putting a little work on you, you'll get more grades. It's fair, I guess.
Good, so hard but fair? Can I say that? Good, I like that. Axel.
I heard that this class is probably just the most across the industry. Get jobs, as I go back to the analysis the most.
Okay, everybody out, I'm done. So my job is done here. Thank you, Axel. Can you give him plus 10, please? No, just plus 2. Thank you. So you didn't hear it was easy then? No, shaking unanimously. No. You know, it's 4 credit lab and writing intensive. What can we say? It's not easy, but is it going to haunt you? Ted is shaking, yes. You're going to see nightmares sometimes? Maybe. It's going to challenge you. I hope it does, because when you're challenged, that's when you learn. So that's my intent, to challenge you, not to haunt you, really. So hopefully you'll be challenged in a good way. Is it going to be boring? Let's see. Who's going to take -2 on this one? No, seriously. For some, it might be boring. Not everybody has the analytical, curious kind of mind towards chemistry. So it's not a bad thing. I hope you just, at the end, feel that you learned something, even if you were bored. Some lectures bore me, to be honest. And you can tell. Sometimes I'm just lecturing, da, da, da. Other times I'm jumping up and down. So you can tell which subject is interesting to me. So we cannot promise that everything is going to be great. But we'll hope overall you're not finding it all boring. Interesting? Axel answered that for me. Yeah. I think for me it is. Most of the subjects are. I hope some of you agree. Useless? It really depends on you. What do you want to do in life? If you want to graduate and go become a business manager, yeah, you will probably find this course useless to you. So it really depends on what you want to do, but definitely we go over so many different topics. You're going to learn analytical. We're going to give you industrial experiences, examples. You're going to find some of this information useful based on what you're going to do after you graduate. So that's that. Okay, let's dive into some introduction about the actual course. So food analysis include what? Chemical analysis and characterization of food components, physical analysis of food, microbiological analysis of food, sensory analysis of food. Come on. Even if you answer wrong, it's still going to be +2. Go ahead.
I think the food analysis include all of those about, but I think this course maybe include A and B.
Have you heard any of my previous recorded lectures?
No.
Okay. You're right. So food analysis is everything. But of course you have a course on sensory, you have a course on biological. You don't have really a course on physical. Mostly this course is A. We don't do much physical analysis in this class, but for example, in chemical reactions next spring, you might be doing some physical analysis like color measurements, for example. Huh? Yeah, fan graduate student. Okay. So what about food composition? So in food composition, when we say food composition, what does it mean? The term food composition. What are we talking about? Do you have any idea? Those of you that already did food chemistry. Yes, go ahead. What's your name?
Kim.
Kim.
I would say it's like the chemical components in it, the actual food that like break it down to what it's actually composed of versus just the physical component.
Okay, well, can you give an example of a chemical component of food? Yes, very good. So composition is actually the makeup of the food down to its components, but the major ones are proteins, Ali? Carbohydrates. In your name again? Caitlin. Fat, protein, carbohydrate, what else? A major component of food, Ted. Minerals, what else? You say your name first? Riley? Water. Water impacts a lot of different characteristics in food, like microbial growth, other chemical reactions, zymatic reactions. Water is an important component of food. What else? Something present in a very small concentration, but vitamins. Okay, so these are the main components of food, the major components, but we're going to learn about other minor constituents as we go through the semester. Yes, Myson? Grace. Good. Thank you, Myson. So now that we know what food composition is about, so we carry out the analysis for what purposes? To meet consumers' demand, to meet government requirement, to determine nutritional benefits, or for quality control? Caitlin, right? Okay. All of the above. We're going to talk about consumer demands in a minute, but for example, consumers might tell you, I want low-fat food. So do you know what a reduced fat milk compared to a low-fat milk in percentage of fat? 2% is a reduced fat milk, and a low-fat milk is 1%. So that's not Sam. Sam? Yeah, and Caitlin. Sam and Caitlin are going to get all their participation points today. But that's good. So if the consumer demands low fat and you want to label 1% milk, you want to make sure you have 1% fat in your milk. To meet government requirements, we're going to talk about government requirements, for example, nutrition labeling, health claims. So if you want to make a health claim, let's say something rich in protein or rich in calcium, it has to have 20% of the daily requirements to call it a rich source of. So you want to make sure that whatever component you're making a claim on actually meets that requirement. Nutritional benefits, do you have the mineral requirement? Do you have the vitamin requirement, protein requirement? Whatever is the requirement that you are actually seeking out of that food you want to ensure by chemical composition. Quality control. So let's say you are processing your orange juice and you have vitamin C in your orange juice. So processing can impact the content of vitamin C. So the quality will be reduced upon processing. So you want to ensure that when you're processing your orange juice, you're maintaining a certain amount of vitamin C in there. And that's an example. Okay. So let's look deeper into consumers' demands and why we analyze food from a consumer's perspective. So of course consumers are looking for quality, high quality. So we analyze the food to maintain high quality for consumers. Safety. So when we say safety, what do we mean by safety? Do we only mean what? Okay, so do we only talk about micro? So yes, micro testing goes in here, but what other than microbial contamination? Toxic components, they might come from microorganisms, so mycotoxins, for example, others.
Just like actual physical threats, like shards of metal or anything.
Okay, extraneous matter, yes, metals, glass. Allergens, and you are? Riley, say your name first, go ahead.
Claire. Could it be like shelf life kind of thing?
Yeah, so in shelf life, what do you really worry about in terms of safety? Production of what, for example? Advanced glycation end products, for example. Or if you have lipid oxidation, you can produce secondary products of lipid oxidation that are not good for us in terms of health, coronary disease or carcinogens. So other safety issues like contaminants, like if you have melamine or bisphenol A, there's a whole lecture on contaminants of concern that we will talk about later this semester, or acrylamide in food. So safety, so it's not only microbial, it can be other than microbial. Nutrition and health, we talked a little bit about consumers wanting high fiber or high protein, low fat. So we really need to make sure that our food, whatever we claim, is correct by analyzing this food. So health claim. So consumers care about health claim. So if we are claiming coronary heart disease, a claim related to reduction of coronary heart disease, which of these would fall under a claim of coronary heart disease? Low in saturated fat, high in phytochemicals, low in free fatty acid. Which ones? You say A and you're a fan, right? Any other? Anybody want to venture other than A? Riley? A and B. Nobody likes C?
Going
And your name is?
Nick.
Nick, -2. No, I'm just kidding. Just kidding, no. +2, but wrong. Nick. Nick.
Wadeström.
Oh,
And also grades, what's wrong?
she's a graduate student.
Okay. And then I'm not sure.
Oh, Devin.
Devin.
Okay, we'll get this. By the end of the week, we'll get this. Okay, so it's not free fatty acid. In this case, free fatty acid is monitored in different situations. So if you have high fat content food and a possibility of lipase presence, for example, so you're looking for hydrolytic rancidity, then you would measure free fatty acid because it impacts flavor. Okay, so in this case, no. Yes, saturated fat, phytochemicals are known to have beneficial antioxidant effect, so that is a possibility as well. So from food industry perspective, so we know why consumers might care, but from the food industry perspective, there are a lot of reasons why in industry they care for analysis of food. Product quality. Of course, high quality will make people want to buy a certain product from a certain vendor or a company. So basically maintaining high standards, good physical properties, good chemical properties, consistent quality. Not every time you have a process you get a different protein content or fiber content or vitamin content. So consistent and high quality product, that's why food industries analyze food. That's one reason. Product development, I'll give an example about product development when developing new product using different ingredients. So what would change in the product? What would you want to analyze? So I'll give you an example in a minute. So both really is meeting consumer demands and evaluate new processes. I'll give you an example about that in a minute. When you change your process, changed an equipment in your plant, how would that impact your product? So that is something that you would do. And you always consider product development and evaluating processes to reduce cost and increase profit. So changing an ingredient from a high cost ingredient to low cost ingredient, how would that impact the product itself, the quality, the consumer acceptability, and would that at all impact profit? New processes that would be more efficient, that will reduce cost, increase profit. So they're always thinking about cost and profit and consumers, but at the same time, they are really considering that they maintain high quality food and competitive. Solve problems. I'll give you an example about solving problems as well, like customer complaints. So I'll give you an example where the customer suspects something in a product or an ingredient, and then the industry needs to analyze the food to try to figure out the problem. We call that oftentimes food forensics, and there is a whole new chapter in this 5th edition. The last chapter in the book is about food forensics. It's a very interesting chapter. Unfortunately, I don't have time in the semester to go over it, but it's a good bedtime story read. So no, I encourage you to read it. Lots of the examples there came from real industry examples. The authors are from Cargill, so they have lots of good stories to tell you in that chapter. How do they investigate complaints and foreign matters in food? Compete. Of course, in industry, it's all about competition. So launching new product or a product similar to another company's product, how do we compete with it? How do we make it similar and better? So a lot of that takes into consideration analysis of food, and I'll give you an example. While we are concerned about all of this, the food industry is bound to government regulations. So throughout the semester, we're going to talk about government regulations. Like next time we talk about nutrition labeling, it's all about government regulation and nutrition labeling. So sampling of food, while for analysis, have to go under what's regulated by the government. So everything we do has government regulations. So here are some examples. So I have few examples to give you in the last 10 minutes, and it's all going to be discussion instead of just lecturing. So let's look at this example about product development. So here's a situation. You are a food scientist, an R&D department, so research and development, and the management want to reduce cost. So they want to go from real butter to vegetable fat in order to reduce cost. So what food analysis test will be involved in this process? Your name, please. Nathan. Pretty nasty off the bat. Yeah, well, sensory analysis, yes, good. What else? What's your name? Yes, spreadability of the whatever they're putting it in. Yeah, texture definitely, because the fat impact texture. That's physical property. Alex? Yes, that's what I wanted to hear. Rancidity, why? Because vegetable oil has what more than butter? Food chemistry. Those of you that finished food chemistry, what would be in vegetable oil characteristic that is different than butter and that might impact rancidity? More of what? Huh? Unsaturated fatty acids. So vegetable fat, if it's not hydrogenated, will have more double bonds, and with more double bonds you have it's more prone to oxidation. So oxidative rancidity is one big thing too. So far we talked about oxidative rancidity, flavor, texture. Yeah, these are good enough for now. Okay, new processes. And this is a true story, true event that happened when I was sabbatical at Cargill. I had to look into the situation where they were producing soy flour, which is high in protein. That's important. It's really high in protein. And they want to become more efficient in terms of time and temperature to treat the soy flour to inhibit trypsin inhibitor. And for safety, so they need to heat the soy flour to a certain temperature for a certain period of time, but they changed the cooker. What types of tests we need to do to ensure that the quality did not change? And this flour is used for growing microbes to enrich media. Amino acid analysis, the same protein is going to be there, regardless of the heat process. So the composition of amino acid will not change, but it's good suggestion though. Ted? Color. Yes, color, browning. So it's very important. In soy flour, you have a small amount of sugar, glucose, and you have protein, so you might end up having Maillard reaction. So yes, color is important. What else? It's a high protein. Protein and temperature, what's going to happen? Protein, temperature, extended time. Yes, your name?
Daniel.
Yeah.
Like acrylamide?
Well, acrylamide can happen, but not at the temperatures that are being used here. You're right about having acrylamide when you have sugar and protein. It's really high temperature during frying, for example, where temperature reaches really high, but it's close. Protein coagulation, denaturation, protein coagulation. So the protein might denature, and when it denatures, it coagulates, and when it coagulates, digestibility goes down. So yes, so these are things that we looked at to make sure that the new cooker did not change the quality of the soy flour. Here's another one. Product complaints. That's interesting. You have a cereal-based pellet that you sell to a producer where they produce snacks. So they basically deep fry it and they package it, and then you end up with a snack that they sell. So the consumer complained or the customer in this case, the customer that produces the pellets into snacks, complained that the finished product was rancid. So you went and got packages of the product from the customer. Now, what would you test to see whether it's your fault, their fault, and if it's their fault, where's the problem? It's some forensics here. Let me see if there's going to be another hand. Were you thinking about answering?
Me?
Hmm?
Oh, well, I guess you'd have to compare the pellet that you have of the chemical composition of the pellet that you have versus what their new product would be in order to determine.
What exactly would you look for in the ingredient versus the product specifically? Yeah, you're right about comparing the ingredients before it became a product. Okay, Sam?
I guess I'd maybe look to see if they added anything and if that's the, like if the things that are added are the participants and producers.
So you're very close here. If we said that this is cereal-based pellet that is deep fried or fried, then one thing they need to look at is their source of oil that they've used. So they would probably sample the oil to see if the oil that they've been using has any oxidative or hydrolytic rancidity. That's one thing. What other thing they want to test? So the package.
I was going to say like packaging, just like testing to see like dropping it, I don't know, like just packaging testing, yeah.
To test what for the package? Permeability? Okay, yeah, permeability of the package for oxygen. So if the package is permeable to oxygen, then the fat in your sample is going to be more prone to oxidation. Nico, did you want to say something?
I was going to say check for microfractures.
Yeah, so another packaging situation. So in this case, we look at the packaging, we look at the oil that's been used, we do analyze the ingredient or the pellet that we sent to them versus the cereal snack that was processed in terms of fat content, free fatty acid, and then any oxidative products. And then we determine what the cause was and whether it was their fault or the beginning material. Another food forensic or more specific food forensic example. So you are a researcher in an ingredient company, and then one of your customers, which is a food processor, when you're an ingredient company, the customer is a food processor, sends you a product formulated with one of your ingredients and tells you there is a sharp foreign matter in the product. What would be your approach to identify the foreign matter? When they say sharp foreign matter, what's the easiest way or thing you would do? Nico.
Yeah, Nico. I would do metal detection.
Metal detection is one, and if it's not metal, what do you do next? Look under the microscope. So there are a lot of different types of microscope. There is a whole chapter, another new chapter, which we won't be able to cover again towards the end of the book, at looking at microstructures. So using microscopy. So scanning electron microscopy, SEM, is very common. CLSEM, confocal laser scanning microscopy, is also very common. To look at foreign objects. So it turned out this was a real case. It turned out that that sharp foreign object was a crystallized sugar. So it wasn't anything sharp, really, glass or anything. So, yeah. One last example I have for you is to compete. So, of course, in industry, you will be facing with competition. And a competitor will be launching a new product, and you want to compete by nature. What would be your approach and type of analysis that you would do? And your name? Daniel. We'll get you. Yeah.
Well, first I would get like a sample of their product and then look at like the nutrition levels of theirs and try to match flavor and texture.
You were spot on at getting their product and looking at the nutritional label. Actually, you wanted to say something?
I was going to look at the ingredient list.
Yes.
See the quality of the ingredients.
So ingredient list, nutrition label, put them together is reverse engineering. So this is something you will be doing in lab next week. So one of the things you'll be doing in our nutrition lab is reverse engineering. And we have an extra credit opportunity where you're actually going to go get a product and you're going to enter the nutritional facts and also enter the ingredient list and then back calculate or back formulate to determine their formulation. How much of milk they added to sugar, to fat, not just there's milk, sugar, and butter in there, but how much of each based on the nutrition label. So there's a program that allows you to reverse engineer. So that's the first thing you would do, to reverse engineer to understand their formulation, but at the same time you go do holistic testing of flavor, composition, texture, and try to match that. Okay, so we have 2 minutes and I'm going to let you go 2 minutes early, and then we'll finish this lecture on Friday and start nutrition label. Thank you.